Hey everybody, welcome back. In this section, we'll be looking at section 1.3 of the Lyle College Algebra book by Pearson. This section is all about complex numbers. So we're going to be learning a little bit of the basic concepts of complex numbers, and we'll also learn to do operations on complex numbers, add, subtract, multiply, and divide, and we'll talk about powers of I. Okay, first we want to think about where complex numbers came from. So let's just think about the equation x squared equals -1. Now you know that when you square a number, the result is going to have to be positive. There's no way we can square a regular number like the ones we've always been used to dealing with and have it come up -1. This appears to have no solution. -1 squared certainly would not be -1. -1 squared would be +1. And +1 squared would be +1. So there's no number in the real number system that can be squared and give a negative answer. So years and years ago, when mathematicians first faced this problem, they thought that they had come upon an impossible situation, and people didn't believe that there were any such numbers, and so they got the unfortunate name of imaginary numbers. They're not, in fact, imaginary at all. It's just that we can't count with them, but they are very useful in lots of applications in physics and engineering. And so the number that produces a -1 when squared is the imaginary number I. It's lowercase script I, and it stands for the square root of -1. In other words, I squared equals -1, or you could say that the square root of -1 is I. Both statements say the same thing. And also sometimes you will see the I referred to as the imaginary unit because its coefficient is 1, and so that's where the unit comes in. Now, if A and B are real numbers, like ordinary numbers that we're used to dealing with, then any number of the form A plus BI is called a complex number. It's complex because it has both a real part, which would be the A, and an imaginary part, which would be the B times I. Now, in the complex number A plus BI, A is the real part, and B is the imaginary part. So two complex numbers are considered equal only if their real parts are equal and their imaginary parts are equal. In other words, if A plus BI is equal to C plus DI, that means the A and the C are the same number, and it also means the B and the D are the same number. That's the only way we can have this complex number equal to that complex number. So in other words, what I'm saying is there's no amount of I that can make up for a difference in the real part, and there's no amount of the real part that can make up for a difference in the imaginary part. The real has to equal the real, and the imaginary has to equal the imaginary. Okay, for a complex number A plus BI, if the B is 0, that means B times I is going to be 0. Therefore, A plus BI would just be A. In other words, if the B is 0, basically what you have is just a real number. So the set of real numbers is a subset of the complex numbers. So every number that you've ever dealt with has been a complex number. It's just that you've only dealt with numbers whose imaginary part was 0, so you never had to think about it before. But every number can be considered a complex number. Now, on the other hand, if A equals 0 and B is not 0, the complex number is said to be pure imaginary. If the real part is 0 and the complex part is not, then what you've got is a pure imaginary number. Alright, a complex number written in the form A plus BI, or you could write it as IB, is said to be in standard form. So when they ask you to put a complex number in standard form, they want the real part, and then a plus or a minus, and then the imaginary part. In other words, not one big fraction altogether, but one term for the real and one term for the imaginary. And that's standard form. Okay, one of the things we need to learn about imaginary numbers is how to simplify a radical that has a negative radicand. What we're going to do is separate that negative number into -1 times the positive of that number, and then we know that the square root of -1 is I. So a square root of a negative number can be written as I times the square root of the positive number. Just always say to yourself, the square root of -1 is I. Okay, so let's practice now. If we have, say, square root of -16, then we think of -16 as -1 times 16, and we split it up into two radicals. The square root of -1 is I, and the square root of 16 is 4. So we have here 4 times I. Okay, with the square root of -70, we split the -70 into -1 times +70, then make two radicals, and the square root of -1 is I, and the square root of 70 will not reduce, so the 70 just stays under the radical. Okay, here we have square root of -48. The -48 separates into -1 times 48, and the 48 separates into 16 times 3. Now the square root of -1 is I, and the square root of 16 is 4, and the square root of 3 won't reduce, so that just has to stay under the radical. Okay, here are a few more examples that I pulled out of the homework, and I hope that you will pause the video here and go through these on your own first, and then we'll go through them together. Okay, assuming that you've taken a few minutes to try them on your own, let's go through them now. So the square root of -25 can be thought of as square root of -1 times 25, and the square root of 25 is 5, and the square root of -1 is I. Okay, here we have square root of -10. The -10 can be thought of as -1 times 10. The square root of -1 is I, but the square root of 10 cannot be reduced, so the 10 stays under the radical. And here we have square root of -288. So I'm thinking 288 is 2 times 144. And the reason I want to use 144 is because that is a perfect square, and I know its square root. So now the square root of 144 is 12, and the square root of -1 is I, and the 2 has to stay under the radical. Okay, now we're about to get into adding, subtracting, multiplying, and dividing. And so let's talk about products and quotients first. Products or quotients with negative radicands are simplified by first writing the square root of a negative number as I times the square root of the positive number. And then we can apply our radical rules. But you have to simplify the negative out from under the radical first before you can use any of your other radical rules. So here's just another caution to remember what I said on the last slide. When working with negative radicands, you have to get the I outside the radical first so that you have a positive number under the radical before you can use any of your other radical rules. Okay, in particular, our multiplication. If you are multiplying two radicals together, this rule where you can combine a product under one radical is only valid when these two radicands are positive. You can't have them negative. So, for example, the square root of -4 times the square root of -9 needs to be simplified first so that we have I square root of 4, which would be 2I, and I square root of 9, which would be 3I. And then we can say 2I times 3I is 6I squared, and of course I squared is -1, so 6 times I squared is -6. What you can't do is you can't say negative 4 times negative 9 is positive 36 and then simplify and get positive 6. That's wrong. You can see it has the opposite sign from the correct answer. So you can't use your radical rules before you simplify and have positives under the radical. Okay, now we have a few examples to go through together. We have square root of negative 7 times square root of negative 7. So we know that before we actually multiply these radicals together, we have to get the negatives out from under the radical. So we'll say that square root of negative 1 is I in both cases. And then we'll multiply I times I is I squared. And square root of 7 times square root of 7 is 7. Alright, now we know that I squared is negative 1. So we have negative 1 times 7, which of course is negative 7. And then we have here square root of negative 6 times square root of negative 10. First, simplify the radicals so that there are no negatives underneath. The square root of negative 1 again is I. And then that will give us I times I is I squared, and the square root of 6 times the square root of 10 is the square root of 60. But notice that I did not write it as 60 because 60 is a larger number, and this is already broken down into 6 times 10. Why would I make bigger pieces when it's easier to work with smaller pieces? So from here, what I can do is separate the 6 into 2 times 3 and separate the 10 into 2 times 5. Now remember that any pair of numbers under the radical, any pair of the same two numbers, gives us a square, and so here I have 2 squared, and the square root of 2 squared is going to be 2. So any pair of numbers under the radical makes a single factor of that number outside. So I'll have negative 1 times 2, which is negative 2, and then underneath the radical I'll have the 3 and the 5, which is going to make 15. And so we were able to simplify that radical without ever looking at the larger radicand. Okay, now these next two are division problems. You see the fraction bar, but the same rule applies. We need to get the negatives out from under the radical first. So both of them, the I will come out of the radical, and now we have, the i's are going to cancel out, so I over I cancels, and we have square root of 20 over square root of 2, which can be put together under the same radical, and then of course 20 over 2 makes 10. So we really have here square root of 10, which cannot be further reduced. And let's look at part D. We have square root of negative 48 over square root of 24. The negative in the top radical needs to come out. That'll make I square root of 48 over square root of 24. But even though we can't cancel the I this time, the same radical rule applies, so we can combine the 48 and the 24 under one radical, and of course 48 divided by 24 is 2, so we have I square root of 2. Here we have 4 more exercises that are similar to the ones we just finished, so I hope you'll pause the video now and try these on your own before we go ahead together. Okay, so now we're going to work through these together. First of all, we have square root of negative 13 times square root of negative 13. The negatives need to be simplified from under the radicals before we go ahead. So the square root of negative 1, of course, is I. So we'll write I square root of 13 times I square root of 13. Now, I times I is going to make I squared, and I squared is just negative 1. And square root of 13 times square root of 13 is going to make 13. So now we have negative 1 times 13, so of course that is negative 13. Now we'll go ahead with part B, and the same thing applies. We need to simplify the negatives from under the radicals before we apply our radical rules. So the square root of negative 3 becomes I square root of 3, and the square root of negative 8 becomes I square root of 8. And again, I times I is I squared, which is going to make negative 1. And then the square root of 3 times the square root of 8 would be square root of 24. But again, instead of trying to write 24, which is a larger number, let's work with the breakdown we already have. So 8 is 4 times 2, and of course 4 is a perfect square, so that's helpful. And in our next step, we'll simplify this radical. The square root of 4 is 2, so the 2 will come outside the radical, and the 3 and this 2 will be left under the radical. So the square root of 4 is 2, and this 3 and this 2 are still under the radical, so 3 times 2 is 6. So we write it as negative 2 times the square root of 6. And here we have square root of negative 30 divided by square root of negative 10. We will simplify the negatives under the radical first, but it's going to end up canceling itself out. So the top one will be written as I square root of 30, and the bottom one will be written as I square root of 10. Now the i's do cancel each other out, and we will write the resulting radicals all under one radical. So square root of 30 divided by square root of 10 becomes square root of 30 over 10. That's one of our radical rules. And then 30 divided by 10, of course, is 3. And so we simplified this one to square root of 3. And here we go with part D. So square root of negative 24 over square root of 8. We do need to simplify the negative first, so that will be I square root of 24 over square root of 8. This time the I will not cancel out, but we can combine these two radicals into one. So we'll have I times the square root of 24 over 8, and 24 over 8 is 3, so here we have I times the square root of 3. Now, on this example, we are asked to write this expression in standard form. And you may remember from earlier, we found out that standard form means A plus BI, where A is a real number and I is, or B is a coefficient of the imaginary unit. And we see that they are separate terms. And that's the big deal here. So, this one, even if we simplify the negative from under the radical, it still won't be in standard form until we split this into two separate pieces that are not joined by a common denominator. So let's do that first. Let's split this expression into two fractions. So I have negative 8 over 4, and I went ahead and did the square root of negative 1 is I, so I have I square root of 128 over 4. But the big deal here is that these are separate terms now, not joined by a common denominator. And now negative 8 over 4 simplifies to negative 2. And this 128, I know for sure 4 will go into 128 because I know that 4 goes into 28. And therefore 4 will go into any number as long as it goes into the last two digits of that number. So I can use my calculator and find out that 128 is 4 times 32. And I still have this 4 in the denominator. Now, I happen to know that 32 is 16 times 2. And I want to go ahead and break that down because the more perfect squares I have under the radical, the better off I am, the easier it is to simplify. And don't forget, our denominator is 4. All right, now we'll simplify this radical. The square root of 4 will be 2. The square root of 16 will be 4. There's already an I out there, and all that's left under the radical is this 2 right here. And now that term is over 4. Notice now that I have a 4 in the top and a 4 in the denominator. Those 4's will cancel, leaving us with negative 2 plus 2i times the square root of 2. And now here is a practice problem that is very similar to the one that we just worked. So I hope you'll pause the video and try it by yourself, and then when you finish we can go ahead together. And so now let's go through this one together. First, I noticed that it says to put it in standard form a plus bi, so I want to not have this common denominator here. So the first thing we'll do is split our fraction into two separate terms. And now let's simplify negative 6 over 2 as negative 3. And now let's work on our square root of 24. 24 could be thought of as 12 times 2 or 3 times 8, but the only way to get a perfect square is to call it 4 times 6. So that's what I'm going to do here. And now the square root of 4 is 2, so that will come outside the radical. And then, of course, these twos cancel, and we are left with negative 3 minus I square root of 6.